Greetings and welcome to the introduction to astronomy. In this lecture, we are going to talk about the celestial sphere as a way of being able to measure positions on the sky from the Earth. So this is what we see when you go out at night and look up at the sky. You are seeing the celestial sphere, which is imagined to be a great sphere surrounding Earth. Now it is actually a geocentric model, meaning that it is Earth centered. Now, while we know that the Earth is not the center of the universe, it is still convenient to use an Earth centered model here to be able to measure and identify locations of things like stars, planets, any other astronomical objects will appear to be on this celestial sphere. So in order to understand it, we need to look at a few definitions here, and I'm going to write them out here, and then we'll look at them in a little more detail on the coming slides. First of all, we have the zenith. The zenith is your point directly overhead. So if you go outside, look straight up, that is your zenith. The horizon is the circle where the celestial sphere meets the Earth. Horizon would be the edge. If you look out toward the edge where the sun rises or sets, that would be your horizon. The celestial poles, and there's a north and south pole, are the projections of the Earth pole to the celestial sphere. And the celestial equator similarly is the projection of Earth's equator out to the celestial sphere. We have the ecliptic, which is the apparent path of the sun, the path that the sun appears to take. And the vernal equinox is the intersection of the ecliptic and the celestial equator when the sun is moving northward. So there are going to be two intersections. Two circles will intersect twice. There'll be the vernal equinox when it's moving northward, and the autumnal equinox when it is moving south. So let's look at these in a little more detail and bring some images up to try to help with this a little bit. So let's look here first of all at the zenith is the point straight overhead. So we have an observer here, and the zenith is that point directly overhead for that observer. It is different for every observer. So what is overhead for a person in one location is not going to be overhead for a person at another location. This is very specific to your very area, as is the horizon. The horizon where the celestial sphere intersects. Over here we see the horizon. You can see what is above the horizon, and you cannot see anything below the horizon. And again, that depends on where you are located. For example, the sun may be up in your location, but will not be above the horizon for another person observing on the other side of the world. Now we also have the celestial poles, and here we look at the north celestial pole, and we take the north pole of Earth and imagine that projected outward, and that would be the north celestial pole on the sky. You could do a very similar thing for the south celestial pole, and there would be a south celestial pole exactly opposite the north celestial pole. This is the point around which the sky will appear to rotate. And then we have the celestial equator pictured here. That is the projection of Earth's equator. So you take Earth's equator here, imagine that stretched out to the sky, and that would be the celestial equator. So they're all tied into Earth, again, Earth centric observations, but that is how we see things in the sky. Now there's a couple others we want to look at that we talked about. So let's look here at the ecliptic, and the ecliptic is the line in red, and that is the path that the sun appears to take. Now the sun will follow along that path, and we see the position here. This is the vernal equinox, which is the sun in March on the first day of spring. That happens when the path of the sun crosses the celestial equator as the sun is heading north in the sky. So the sun is getting further and further north. 3 months later, it will reach the summer solstice in June. 3 months after that, it will again cross the celestial equator, but this time heading south. And then finally, the um, winter solstice will be in December. So those are the beginnings of each month, and they have a the beginnings of each season, and they have a very specific notation. The vernal equinox, the beginning of spring, the sun crosses the celestial equator heading north. In September, the autumnal equinox crosses the celestial equator heading south. In June, it is furthest above the celestial equator, so highest in the sky. And in December, it is furthest below the celestial equator, so it is lowest in the sky. Now let's look a little bit about what this means. And we will see things that appear because of this: circumpolar stars. So the pole would be someplace right at the center here. This would be our north celestial pole. North celestial pole. So everything seems to be around this. Polaris happens to be the bright star near to the north celestial pole, but not quite exactly at it. And the stars will all revolve in circles around the pole. So you can see that here. And the greater the distance, once they get far enough away, sometimes those arcs will intersect your horizon off in the distance. And those are when stars rise and set. Those stars closer to the north celestial pole will become circumpolar stars, stars that will always be visible. For those in far northerly latitudes, those are things like Ursa Major, which contains the Big Dipper, and Ursa Minor, which contains Polaris, the North Star. Now, we also want to look a little bit about navigation, and astronomy was used for navigation for a long time. And that is because the altitude of the pole, how high it is above the horizon, tells you your latitude. So, for example, the pole will be 40 degrees above the horizon for an observer at a latitude of 40 degrees. It will be on the horizon for someone at the equator. It will be at the zenith for an observer at the pole, and it will not be visible for an observer that is south of the equator. Although they will have a south celestial pole, there just doesn't happen to be a bright star located near that. Now, this is one way to navigate, by being able to keep track of a ship at sea and keep track of what the altitude of the pole star is. So if the pole star is getting higher in the sky, you find that you're going north. If it's getting lower in the sky, you would find that you are heading south, and you could adjust your course appropriately. Now, within the celestial sphere, we do see the daily motion, the rising and setting of all objects caused by Earth's rotation. We also have an annual motion pictured here, which is because of the revolution of Earth around the sun. So the Earth is moving, and that means that the positioning of the sun appears in different constellations. The sun moves by about 1 degree per day eastward relative to the stars, and will slowly move through the constellations of the zodiac, taking about 1 month to go through each constellation, although that varies depending on the size of the constellation and the exact positioning. Planets and our moon will also travel through these constellations. So these are very prominent constellations, and we'll look at them in more detail in another lecture. But they're not prominent because they're unusually bright. They're prominent because they are located near the ecliptic, which means that the sun, moon, and planets will pass through them. Now, when we look again at the celestial sphere and those motions, the planets have a very unusual motion, that they wander among the stars. So the patterns of the constellations stay the same. The planets will change, and we will look at this more coming up as well. But they undergo what is called retrograde motion, that not only will the planet move through the stars, but it will stop, go backwards, and then go forward again. And we'll see that this took a while to be able to explain. We also use the astronomical objects for time. So, for example, we use the sun gives us our day and year by the rising and setting of the sun, technically the rotation of Earth, and the path of the sun through the constellations. Again, the Earth revolving around the sun, but that gives us our year. The moon gives us our month. And where do we get a week from? Well, there were 7 objects known to the ancients, the 5 planets plus the sun and the moon, that gave us 7 days in the week. So again, some of this will come back to a little bit more detail in future lectures. Now let's look a little bit about the constellations. Constellations, the definition has changed. The ancient definition is a group, or was a grouping of bright stars, and you see a prominent region like this where you'd have some mythological figure, and that would be named around that. So here we see the constellation of Orion here, and that it has the 3 bright stars in the belt and another bright stars outlining the body. And that was how they were named. But there were parts of those that were not really part of a constellation if there were no bright stars around. On the other hand, the modern definition about 100 years ago was to simply say that every part of the sky was in a constellation, and we made 88 constellations, using some of those historical ones and making up some new ones as well to fill in areas. So every part of the sky was in one of those constellations. Here we again see Orion, but the lighter area is the border of Orion. And everything within that light box is part of the constellation of Orion. There may be no bright stars near it, but it is similar to a national boundary. So the boundaries of a country may be defined even if there are no large cities anywhere near it. So the large cities would be like the stars. The constellation would be like the country boundary. So every point on the sky, no matter what point you pick out, would be in one of these constellations. So let's go ahead and finish up this section with our summary here. And what we've looked at a little bit is the celestial sphere of a way of observing the sky. It will depend on your observer's location. So the appearance will be different depending on where you are on Earth. And the planets and stars have different motions. The stars move together as a group, whereas the planets tend to wander through the stars. And we looked at the modern and ancient definitions of a constellation and how that has changed. So that concludes this lecture on the celestial sphere. We'll be back again next time for another topic in astronomy. So until then, have a great day, everyone. And I will see you in class.